Okay, so starting with the first one, it says evaluate the expression, so use order of operations to solve it. So starting within the parentheses and the exponents, so I'm going to start with the exponents here. And bring everything down. Cool. 36 divided by 3 is 12, and 12 times 4 is 48. And yes, this is worth points. Just write down all the work. Two times 48 is 96. Minus 96 is 76. For the next one, they give us variables and they tell us what the values for the variables are. So it's just like the last one. The only difference is we have to plug in those values before we start calculating. Then you'd solve anything that you could solve inside the parentheses first, but there's nothing inside the parentheses you can solve, so we're going to go to the exponents. And then we're going to work with the multiplication. 3/4 times -8. You could do that in a calculator. Comes out to -6. And then 3 times 1/3 is just 1. So just kind of cancel that out. -6 minus 64 is -70, and that is your answer.
Couldn't we just put those in decimal form?
If you prefer.
So we have pencils right now.
You have pencils?
Would that work?
Okay. For the next one, it says name the property illustrated by each equation. So just to make a note of the different properties that could show up here, one is commutative. Then we had associative, distributive, and identity. And these are popular on SATs and standardized testing as well. So just to review, commutative would be like 2 plus 4 equals 4 plus 2. And remember, these are also kind of like notes because you'll be able to use this on the test. So just jot down an example for yourself. There's also commutative property of multiplication would be like 2 times 4 equals 4 times 2. Same diff. And then associative property, that's the one that you often see with parentheses, like 2 plus 4 plus 3 equals 2 plus 4 plus 3. So for associative, the numbers actually stay in the same order, 2, 4, 3, 2, 4, 3. The difference is they are grouped in the parentheses differently. And distributive, you should be pretty good with x plus 2 times x plus 3, and then that would become 2x plus 6.
Can you zoom in a little?
Yeah. And then identity, I remember because the number keeps its identity. For example, 2 plus 0 equals 2, keeps its identity. Or 2 times 1 equals 2, again, it keeps its identity. So then considering that, naming this property, we would look and see if the numbers are in this 5x, 4y, 3x, 5x, 3x, 4y. So the order changed, these two switched places. So that is commutative property. And then in the answer choices, it'll have commutative property of addition and commutative property of multiplication. Where the switch happened, it's addition, so this would be of addition. Okay, next. Find the additive inverse and multiplicative inverse of a number. Okay, so additive inverse, you want the two numbers to add to 0. And then multiplicative inverse, you want the numbers to multiply to 1. So you need to find out what number you would add to negative 1.6 to get 0. Which you probably don't need to write that all out, but if you added 1.6 to both sides, x equals 1.6. So one of those answers is 1.6. And then for multiplicative inverse, you need something that you'd multiply it by to get to, so negative 1.6 times x equals 1. So to find that number, you would divide both sides by negative 1.6, divide by negative 1.6. And if you plug this into a calculator, it comes out to x equals negative 0.625. So negative 0.625. And that is your answer. Oh, now I'm too zoomed in. There. Okay. Ready for the next one? Okay, next one, solve each equation, check your solutions. So we have an absolute value symbol in there. Before we deal with the absolute value, we need just the absolute value on one side. So we're going to get everything else on the other side. So we're going to subtract 5 from both sides. Going to divide by negative 3. Until we get this. Okay, so now I have just the absolute value on one side. What we're going to do is put this equal to a positive 4 and put it equal to a negative 4 and solve it both ways. So I'm going to do 2 plus 2w equals positive 4 and 2 plus 2w equals negative 4. So I get w equals 1. And w equals negative 3. Next one. Write an algebraic expression to represent each verbal expression. 5 times the sum of a number and 1. Sum of a number plus 1, and 5 times that. Why did I use m? That's what the answer key had. That's why I used m. Okay, number 7. Find f of negative 1, and it gives the function here. So we're just going to plug in negative 1 for x and solve. We get negative 3. Okay, number 8, write this in standard form. Okay, what is standard form? Standard form is ax plus be y equals c. So we just have to rearrange this into this format. So moving this over here, positive 5x plus 3y equals negative 1. And that's it. So something to also take note, this shouldn't be, so no negatives, that beginning coefficient, no negatives, and no fractions. So if it had a negative number there, you would multiply everything by negative 1. Or if it had a fraction, like if it was 1/3 x, you could just multiply everything by 3 to get a whole number. Next, find the x-intercept and y-intercept of the graph. Okay. To properly look at this, actually there's different ways you could do this. You could plug in a 0 and solve, or you could get it in y equals mx plus b format. Do you have a preference here? Okay. So to find the x-intercept, y would equal 0, and then to find the y-intercept, x would equal 0. So we would plug that into the equation. 3x minus 2 times 0 equals 12. So 3x equals 12 and x equals 4. So then your x-intercept would then be 4. And then for the y-intercept, you plug in 0 for x, 3 times 0 minus 2y equals 12. And y equals negative 6. So 6. And then the answer would just be 4, semicolon 6. Okay, thank you. Next. Oh, what's up? Yes, this should be negative. Appreciate it. Okay, next. Find the slope of a line that passes through 2, 6 and negative 7, 8. Slope formula. Slope is y2 minus y1 over x2 minus x1. This would be x1, y1, x2, y2. And then we can plug our numbers in to solve for slope. So 8 minus 6 over negative 7 minus 2. 2 over negative 9. So the slope is negative 2/9. Okay. Number 11, write an equation in slope-intercept form for the line that has a slope negative 4 and passes through these points. Okay, so the equation would be y equals mx plus b. We're told that the slope is negative 4, so y equals negative 4x plus b. We need to find what this y-intercept is. The best way to do that is we're going to plug in the x and y and solve for b. So this would be 2 is negative 4 times 1 plus b. So I get 6 as my y-intercept, and then I can just plug that into this. So y equals negative 4x plus 6. Okay, we're going to do one more just because it's like in that same sector of types of problems. Okay, so write an equation in slope-intercept form for the line that passes through 0, 5. So that is actually the y-intercept, which is cool. That makes our life a little bit easier. And is parallel to the line whose equation is this. If it's parallel, it would have the same slope. Just a note, perpendicular slopes would be negative reciprocals. What does that look like? It means like 2/3 would then be negative 3/2 as a slope. Like a negative flip. But for parallel, we just need to find what the slope is, honestly. Negative y equals negative 4x plus 3 divided by negative 1. Y equals 4x minus 3. And then a line parallel to that would have the same slope but a different y-intercept. So it becomes y equals 4x plus 5, which our y-intercept is right there. Okay, that's it for today. Put this in a safe place because we'll take it out and finish it tomorrow.